The first example is an example of students working on a chi-square test, which is a statistical test that allows you to compare the significant difference between numbers. I chose this to be the example of a decreasing cognitive level because the students really simply only have to know the formula and then they have to add in numbers to the formula. So this would be going from a level of where the students were doing procedures with connections down to procedures without connections, because basically they only have to choose which numbers they put into which parts of the formula. So it's pretty much just a plug and chug type situation. In the next example, the students are determining how to calculate the recombination frequency, which is basically the frequency at which alleles cross over during the process of meiosis. Crossing over is when um, genetic recombination occurs and genetic variation arises in a population. Before the students started, I did not tell them how to do the recombination frequency. I simply explained how a problem was set up for them, and then I asked them to determine how they would figure out a number by which the alleles crossed over. So they had to look at the data, and they were able to determine that part of the outcome of the genetic cross resulted in babies that looked different from the parents. Therefore, we call this a crossing over event. So the student here is explaining how she determined what the crossover frequency or recombination frequency is between two genes for fruit flies. I chose this to be a maintaining the cognitive level because the first time she did the problem, she did it incorrectly. But I did not describe to her how to fix the problem. I simply asked her a question and told her that the way that she had solved the problem was incorrect. So then she was given a chance to rethink the problem without any new hints other than that the answer was incorrect. Therefore, she had to maintain the cognitive process. She thought about what way she could actually figure out how many offspring out of the total offspring were actually recombinant offspring. So she's going to describe how she did that.
6, which is one of the ones that wasn't parental, and then 185, which is also non-parental, and I divided them by what they should have been, the 575, and so when you add them you get 391, and then I divided it, which is 0.68. So I'm guessing that that's like the probability of them doing that, so like 68% of the time they would recombine. That's my guess.
Okay.
So then, wait, for all of them? Could I just like subtract one? Subtract that from one, and then the opposite of that? Is it?
Not quite. Not quite.
Do I divide it by 2,300?
She says divide it by 2,300. Does that sound like a good idea to divide by 2,300?
Is that the total number of babies?
That is the total number of babies. Okay, great. So why should she why should she divide by 2,300 babies?
Because it's all of them.
All of the babies, right? When you divided by 575, what were you actually dividing by?
Just one.
Just one, like, phenotype possibility. Yeah. Okay, fantastic. Okay, can you please do that now?
Yeah, I got 17, so it'd be like 17% of them crossed over.
Okay, great. Can you write that on the paper? I'm so sorry.
Sure thing.
I know, it's a struggle. All right, great. So what are you saying that 0.17 is?
That would be then how do I say this? That's like the percentage of the babies that did cross over.
Yes.